Alrighty, so let's get started. As you can see by our I can statement, we're going to be finding the zeros of polynomials and describing what they mean and how we can describe a graph if we just have the factored form in the zeros. So a zero, I need my pen tool. I need my pen tool on a reasonable sized pen. Reasonable sized, I said. The word is zero. A zero of a polynomial function is an x value for which the function is equal to 0. Meaning, if x equals literally anything, I'm just going to use a variable a, that means y equals 0. So we use the 0 product property to find the zeros of a function. What this means is that any two variables or any two things multiplied together, if they equal 0, then that means one of them is equal to 0. How we write that? So if a times b equals 0, that means either a equals 0 or b equals 0. So, to put that in the context of a polynomial, I'll use this as an example. So I'm just going to use, I can use all of it. So x plus 1, x minus 2, and x plus 4. So if we're looking for the zeros, that means f of x equals 0 or y equals 0, so we set this equal to 0. And based on this property, that means each one of these, if one of them equals 0, that means the whole term equals 0. So we would have, and this is also our first step for our table, so that's why we're doing it now. So what we do is we set each individual piece equal to 0. So we'll have x plus 1 equals 0, x minus 2 equals 0, and x plus 4 equals 0. And then we solve for x. So this first one will have x equals minus 1. The second one will have x equals 2. And our last one will be x equals minus 4. You can write it in that fashion. You could write x equals each time. It's up to you. It's perfectly fine with me if you just do this. So what it's saying is that when x equals negative 1, 2, or 4, or negative 4, y equals 0. So since we're just given the factored form of a polynomial, we want to know what properties we can find based on that. And we do that by making a sign chart. Where? How we make a sign chart is we put our zeros down, or our factors. So we'll have x plus 1, separate it. We'll have x minus 2, x plus 4, and then we'll have one that I'm going to shorthand label called product. Now how we do a sign chart? We work with different values. So we start with our lowest 0, and we do negative 4 is less than x. So when x is less than negative 4, if we put that any value that is less than negative 4, we could go negative 5. If we put that in for x, what is the sign for it? Meaning, is it positive or negative? So if we put negative 5 in for this first one, we'll get negative 5 plus 1, we'll get negative 4 out, meaning our sign is negative. If we do the same thing for the second one, we'll find that it's also negative. This could be any value that is less than negative 4, it does not matter. If you want to actually put in the numbers, you can do negative 5,000, negative 5.1, negative anything, that as long as it's less than negative 4, you'll find that all of these are negative. So if we multiply this is where the products table comes in. We take each column and we multiply them together. So negative times a negative is a positive. Positive times a negative is a negative. So our output is a negative. Then we do our next range, which is, I'm sorry, I wrote this in the wrong order. So x is less than negative 4. That is the correct order. It should be written in for what I was saying. So we'll have negative 4 is less than x is less than negative 1. We always go from smallest to largest because it just helps us with our sketch later. So if we put a value in from this range, we'll say negative 3. If we put a negative 3 into our first one, negative 3 plus 1 is negative 2. Our value is negative. Same for this. You put a negative 3 in, minus 2, get negative 5. It's also negative. And for this last one, if we put a negative 3 in, negative 3 plus 4 gives us positive 1. So we have a positive number. And for our last column, we multiply all the columns out. Negative times a negative, we already know it's a positive. Positive times a positive. Our output is positive. Then we take our next range. So negative 1 is less than x is less than 2. I think you could probably see, or at least guess. So since we're now outside of this one, our first one is going to be positive. We put any number that is greater than negative 1, we're going to get a positive value out here. Still going to get a negative for our second one. We'll get a same for our positive. Our last one, when we multiply this out, we'll get a negative. And our last range is when x, so we'll write it like this, so 2 is less than x. You can write it as x being greater than 2 if that helps you. So that would look like x is greater than 2. So what we'll find is they're all positive now. We get a positive out. So how do we use this? Well, we're going to use this to draw a graph, or sketch a graph. So if we draw this real quick, we need positive, we need a positive 2, we need negative all the way up to 4. So we write our points. So we have zeros at negative 1, negative 2, negative 4, and positive 2. So how this helps us is that it tells us where the line is, whether it's positive or negative, during these different sections. So during our first section, when x is less than negative 4, we know that it is negative. When x is between negative 4 and negative 1, we know it's positive. That's this one right here. The first one was our top one. Our second range, when it's between negative 1 and 2, it is I accidentally scrolled. It's negative. And then our last range is positive. So since this is just a sketch, you can draw your line however you want, as long as it crosses the x-axis at these points. So the reason that is because, let me change my transparency back. Come on. So whenever we pick a number that is less than negative 4, I just chose randomly negative 5. When we input negative 5 in, so if we do negative 5 plus 1, that gives us negative 4. So that's a negative value, meaning every number that's less than negative 4. So when it's in this range, we get a negative out for this variable, or for this factor. So that means this, for this one right here, it is negative. We would do the exact same thing for each other factor. So we'd have negative 5 minus 2. That gives us negative 7. So it's negative. And that's just for this range, just for when x is less than negative 4. Yep. And then we do the same thing for this. So if x is less than negative 4, I just picked a negative 5. You can pick any number that's less than negative 4. So we do negative 5 plus 4. We get negative 1. Still comes out as a negative number. The reason we get them for the product, we take each of these and multiply them together. You can imagine them as -1, whatever, we're only looking at the signs. So if you multiply two negatives together, we get a positive. And then a positive multiplied by a negative gives us a negative back out. That's why. Okay. So for the second one, just going to erase this real quick because it's going to be similar. We need a number that is between -4 and -1. So we can arbitrarily, I'm just going to choose -3. Yes, you may. Arbitrarily choosing -3, if we, because as we stated before, at -1, at 2, and at -4, it equals 0. We already know what the function is at those points. We're looking for if the function is positive or negative beyond those 3 points. So what this tells us is that whether the function is positive or negative when it's not at these 0 points. So doing the same thing as we did before, so it'd be -3 plus 1. We get -2 out, so that's a negative number. Second, then we can do same thing, so -3 plus or -2 gives us -5, also a negative number. But if we did -3 plus 4, we get a positive number out. We get 1. So because of that, it's positive. We can pick any number in this range. So if we say I did -2 plus 4, we get +2. If we did -3.9999999 into infinity, it would still come out positive because it's just small enough below the +4. So if we did 3.9 or -3.9 plus 4, well that's what, so we get positive 0.01 or 0.1. So to do the graph, we're literally just drawing a graph. So I'll just redraw this. So we're literally just going to sketch a grid first. So we have our we have our y-axis, we have our x-axis. I'm going to draw out some ticks just so I know where we're at. So that's going 4, 2, 3, 4. Doesn't have to be drawn perfectly to scale, but just try your best. So these are +1, 2, 3, and 4, -1, -2. I can't write that small. Why does it think I'm holding control? Why does it think I'm holding control? There we go. So -2, -3, -4. So if we look back over here, we have zeros at when x equals -1. So that means that x equals -1, it's on the x-axis. When x equals -4, it's on the x-axis. And at x equals 2, it's on the x-axis. So then I did these dotted lines to just indicate where those points are. You don't have to draw these dotted lines if you don't want to. You don't have to draw the highlight if you don't want to. So all this is saying now, so our first range, when x is less than -4, that's when x is anywhere, let me pick a different color. That is when x is less than -4, so that is anywhere after this point. So if it's anywhere to the left of this first point, we know that it's negative based on our chart. So that's going to be negative based on our chart. Because we found in this first column, or this first row, that the product is negative. So our second range, so that is between -4 and -1, we found that using our chart, it's positive. So that can be literally anywhere above the graph. So our third range, we found that it was negative between -1 and 2. So I'm just doing these highlights to indicate that this is the range that it can be in. You don't have to do these sketch highlights, I'm just showing you. So then our last range is when x is greater than 2. We found that it to be positive. So now when we actually sketch our graph, if it lets me pick a color, thank you. All we have to do is make sure that our line is within the correct ranges. So that means something like this. It could be steeper, it could be shallower, whatever you want, as long as the line crosses through the shaded region when it's supposed to and then crosses the x-axis at the points. That's our rough sketch of the graph. So we're going to do one more, and we're going to move on. Unless you guys want me to do the last one, but let's just go over this first one. First off, we need to find our zeros. So we set each of these terms equal to 0, and then solve for x. When we do that, we get x equals -1, -4, and +1. +1. Let's write -1 again. And then for our sign chart, we just start with one of our factors. It does not matter what order for our sign chart. So x -1, x plus 4, we'll have our product. So our first range, we always start with our lowest 0. So when x is less than -4, since it's our lowest value, when x is less than that value, for our sign chart, they're all going to be negative. And what we found out before was when they're all negative, our product is negative. Because negative times negative, positive, positive times negative is negative. Our next range, we take our smallest and our second smallest. So we'll go -4 is less than x is less than -1. When we put that in, I'm going to write that just a little further over to the left so it's not in the way. So -1, -4 is less than x, less than -1. When we find that, put that in, we'll find out this first one here. Yes, the first one goes positive. Nope, ignore that. Ignore that too. First one's negative. You can always confirm this by putting a value in. So if we go -2, plug a -2 into this first one, we get a negative out. If we plug a -2 in this second one, we get another negative out, because it's -2 minus 1, -3. If we put a -2 into this last one, -2 plus 4 is +2. So let's get a positive out. And you'll find it is a similar type deal. So when we multiply all out, we'll get a positive. For our next range, we go -1 less than x is less than 1. Our first one is still negative. Scratch that. Our first one's still positive. I'm sorry. I'm making this a little more confusing. So I'm just going to put in a value. If we put 0 in for x, we get a +1 out, because 0 is in between -1 and +1. If we put 0 in for x on the second one, we get -1. If we put 0 in for the first one, we get +4. When we multiply positive times a negative times a positive, we get a negative out. And finally, when 1 is less than x, or x is greater than 1, so if we put 2 in, we'll get 3 for this first one, positive number. If we put 2 in for our second one, we get +1. We get positive all across the board. And then we do a similar sketch. So we'll start with our x-axis and our y-axis. Draw enough ticks to capture everything. So we need 1, 2, 3. Let's go 1, 2, 3, 4. So we have zeros at -4, -1, and +1. I personally like to draw the dotted lines just so it helps you know where to break it up. You don't have to if you can see where they're supposed to go. So when x is less than -4, so anywhere to the left of here, it is negative. When it's between -4 and -1, it is positive. When it's between -1 and +1, it's negative. And when it's between 1 and infinity, or when x is greater than 1, it is positive. So similarly to our first one, we're going to have a graph that looks something like that. The only thing you have to make sure is that it crosses the x-axis at the zeros. Would you guys like me to do this last one, or are you guys good to move on? Okay. So next, we're going to look at these properties a little more in depth. So we're going to find the zeros of our polynomial. They're up here. So our first zero, x plus 1, when we set it equals 0, we'll find it is x equals -4 and x equals +2. You can also see that on the graph. Hits the x-axis at -4, hits the x-axis at +2. When we're talking about degrees of binomials, we're actually looking for the power that's on the outside. So you can see, you don't see one because it's implicit that x plus 4 is to the first power. And when anything's to the first power, it is considered odd. And as we see in our graph, it doesn't touch, it doesn't just touch the x-axis, it crosses the x-axis. Same thing for our second one. So we can imagine that x to the -2 is to the first power. So it's also odd. And as we see in our graph, it also crosses. So now we'll see that we have x plus 4 squared. And if you'll notice, our zeros are the exact same. Because if we set x plus 4 squared equal to 0, our first step would be to take the square root. The square root of 0 is 0. We get x plus 4 equals 0, so we'll get x equals -4. And our -2 is the same, so it's still +2 and -4. But as we noticed before, that this is squared, so we have an even degree for our first term. Binomial 1 is always going to be x plus 4. Binomial 2 is always going to be x minus 2. If it helps you, we'll write it again. So x minus 2. And as we can see, it doesn't cross the x-axis, but it just touches it and then bounces away. And for our second one, it is still odd. It's still an odd, and it crosses. I don't know why I highlighted that point. I meant to highlight this point. So next up, we have x plus 4 cubed times x minus 2. And just like before, our zeros are the same. But as you can see, our degree for our first term, our first binomial, is odd this time. And as we see here, it crosses past the x-axis, meaning it goes from positive to negative on the yes. Our function goes from positive to negative. Or, yes. I keep saying or. And just like before, because we never changed it, our second binomial is still the same, odd, and it crosses. Now we're back. Now we're up to x to the 4th. Still the same deal with our zeros. Except this time we have an even degree, and it just touches. It doesn't cross and go negative to positive. It is negative and stays negative after it touches the x-axis. And our first one is still the same. It is odd, and it crosses the x-axis. So, as you might be noticing, when the degree of a binomial is even, it does not cross the x-axis, and if it is odd, it crosses the x-axis. This is what we're getting into next, and what we're kind of looking at just then was multiplicity. Multiplicity is the number of times a factor appears in the factored form of a polynomial. As we saw before, so that's going to look something like y equals x plus 2 squared. So actually, I'm just going to use the ones that were given. just because they're a little easier. So y equals, we'll have x plus 4 squared and for over here we'll go y equals x plus, I can just do x plus 4, it's odd. So on a graph, this would look like this one specifically. So it is a quadratic equation translated to the left by 4. This equation is going to look like this. It's going to be a quadratic that just touches the x-axis when x equals -4. For odds, it is going to be at x equals -4, so I'm just going to write -4 here. -4. The line switches signs from negative to positive. It crosses the x-axis. Basically, if it crosses the x-axis, that means our degree is even, or our degree is odd. If it just touches, our degree is even. Yes? No? Okay. So next we're going to look at these and determine what the graph does at each of these zeros just by looking at the multiplicity. So first we need to find our zeros by setting each of these terms equal to 0. So x equals 0. Well, that one's already solved. So x plus 4 equals 0. We get x equals -4. And x minus 1 to the 4th equals 0. First thing we're going to do is take the 4th root, which basically to the 4th and to the 4th, x minus 1 to the 4th, the 4th and the 4th root cancel, and we just get left with x minus 1. The 4th root of 0 is 0, and we just get left with x equals +1. So, as you can see, our first one has a degree of 1. That means it's odd. So at x equals 0, the function crosses the x-axis. So this is a root. So you remember square roots. It's the same symbol as a square root. Let me draw it more properly. Except since we're doing the 4th root, because we have x minus 1 to the 4th, we write a little 4 out in front of it, just to indicate that we're taking the 4th root. You don't actually have to know how to take the 4th root. It's just to show that if you take the 4th root of anything to the 4th root, you just get the same thing out. So that's why when we took the 4th root of x minus 1 to the 4th, we just get x minus 1 out. So our next one, x plus 4, it is an odd coefficient, so it just crosses as well. So gotcha. So at x equals 4, it crosses. And as we saw in this last one, it is x minus 1 to the 4th. That's an even, so it just, so at x equals 1, it just touches the x-axis. If I could spell without saying wanting to jump all over the place. So for this last one, I'm going to have you guys help me. So for our first one, so x plus 3, our first thing is always going to be set it equal to 0. What's our 0? -3. Perfect. Oops. So x equals -3. Does it cross or just touch? Look at the degree. It'll cross because it's to the power 1, which is an odd degree, so it's going to cross the x-axis. So for x minus 3, as always, our first step is going to set it equal to 0. So that means x equals Yeah. So x equals 3. And looking at our degree for x minus 3, is it going to cross or is it going to touch? The cross. So then we have x minus 1 to the 5th equals 0. What is our 0? So yes, but that's a dangerous way to look at it. The answer is just 1, so all you have to do is look at the inside and solve the inside for 0. You don't have to bring in the 5th into anything. The reason why I say, because you are correct, because 1 to the 5th is just 1. But if, say, this was negative 2, 2 to the 5th is not the same thing. So, it is x equals 1. So we have a degree to the 5th. Does it cross or just touch? It crosses. And then last but not least, we have x plus 2 to the 3rd equals 0. So that means x equals -2. And we have a degree of 3, so that means it crosses. And that's it for